Welcome to the Algebra 2 PLC, where we're discussing the exam review items for Semester A. I'm John Chase, teacher at Richard Montgomery High School.
And I'm James Key with the MCPS math team. We received an email about problem 18 in the semester exam review packet, so let's go ahead and take a look at that item now. Rather problem 26 we're up to. We are rolling here. In 26, we have a house that's valued at $100,000 at the beginning of the year 2015, and we're told that its value increases, get this, by 30% each year. Now that's what I'm talking about, okay? This is a multi-part question in which students are asked to write an equation that's able to predict the value of the house after a certain number of years. They're asked to determine the value at a particular year, 2019, and then to analyze the average rate of change of the value between these 2 years. So in thinking about how students might approach that, in particular, how can we capitalize on the information that we know the value increases by 30% each year? And I'm just going to emphasize a conceptual way to approach this. So if you take all of the value that we start with and increase that by 30%, we're now at 130% of the original value, which tells us that the year-over-year growth factor is 1.30. So because we're mavericks, we decided we want to do this problem out of order. We're actually going to address problem B first and then circle back to part A. So John, how would you think about how to determine the value at the start of the year 2019?
All right, well, where are we starting with? Starting in 2015, and we have a value of $100,000. And this little table that we're going to show you lays it all out. Now, I don't know that we would do this, I would do this, and our students would do this every time, but I think it's helpful to go through once conceptually, especially if there's a question that arises around this. Then why not do it? Like, show them at least once why this is happening. So in 2015, it's unarguable that $100,000 is the value because we were told that in the problem. In 2016, it's also somewhat unarguable that it's 100,000 times 1.30. See the conversation that James just brought up a second ago. We're increasing the value by 130%. And we can just check that that's true too. Multiply it out. Do we get what we kind of intuitively expect to get? 130,000? Yeah, we do. And then in 2017, we're multiplying the previous result by 1.30 again and again and again. And now we're like just aching for a better way to do this, aren't we? So, so it should occur to students that a nicer way to write this is 1.30, this long product, as 1.30 to the fourth power. So that's what our value is in 2019, and we can go back and use that same notation for all of these. In general, what would it be in 2015 plus t? Well, I mean, now we can generalize on this idea by just putting a t in here. And I think we're done. I think that was it. I think that knocks out both parts B and part A. So that was a really useful analysis. Again, let's emphasize as we shift our instruction, let's make sure that students are accessing a conceptual understanding and not just blindly following a procedure with that. Let's see, in part C, students are asked to look at the average rate of change over that 4-year time period. So here we have the year 2015, and then 4 years later, it's 2019. And just to highlight the question stem once again, so that's fresh in our mind, what is the average rate of change of the value of that house between those 2 years? Well, let's take a look. Having done the calculation, the increase in the value of the house between 2015 and 2019 is approximately $185,000, and that occurred over a 4-year time period, which means that on average, the year-over-year increase is about $46,000. So in 1 year, the value increased by $46,000, and then that happened again and again and again until it reaches this peak value right here. Just something to notice looking at this graphical display, the pink graph is showing the graph of the formula that John talked about on the previous slide.
where he came up with the expression, the value Y of the home after T years is given by the expression 100,000 times the growth factor 1.30 applied T times. And so this pink graph is just the graph of that equation. And I found it interesting to note that the average increase is larger than the amount by which it actually increased in year one, but it's smaller than the amount that it increased by in that final year.
Yeah. One other thing I should say is I didn't actually compute that value for 2019. For those viewing at home, it's $285,000 and $285,610 in case you were wondering. There it is on the screen. And I think that's a wrap for this problem. Thanks for tuning in again to the Algebra 2 PLC. Hopefully this has been helpful going through these exam review items.